Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
On this episode, we get into a topic that's top of mind for lots of companies: how to optimize warehouse investment so that you're getting the most for your business. Tristan and I are joined by two people who have a lot of knowledge on the subject: Brad Culberson, a data platform architect at Snowflake, and Niall Woodward, co-founder of Select, a warehouse optimization startup. We get into practical advice on where to start the optimization journey, and we dive pretty deep on what's going on under the hood in your warehouse to understand which queries are ripe for scale out or for optimization.
Pretty deep is right. I think that this is maybe one of our more in-depth technical episodes from an analytics engineering perspective ever. We're always trying to balance the desire to stay accessible in the content that we're producing with the desire to go deep in areas that I know that you and I are both fascinated about. But I thought it was really fun getting into the weeds with Brad in particular about some Snowflake access patterns that I've observed using the product over many years. And it was neat to get the advice from an expert there.
Yeah, it turns out there's both an art and a deep science on how to pick the right warehouse size for your queries. And we learn a little bit more about why that is the case in this episode. So it was a fun one for me too, and certainly very practical for those that are thinking about how do they make the most of their cloud spend. So without further ado, let's get into it.
Brad and Niall, welcome to the Analytics Engineering Podcast. I'm going to let you introduce yourselves in a minute, but I want to introduce the episode from a place of maybe putting my own foot in it. This was back in September of last year, 2022. I wrote an issue of the Analytics Engineering Roundup that talked about cost optimization in Snowflake. And I linked to a post, and it turns out that some of the things that I said there, and some of the things that the post said there, were not correct. And I heard about it. I heard about it from a number of people. It was probably, I've probably gotten a lot of things wrong over the course of 6 or so years of publishing that newsletter, but I've never heard so much feedback about getting something wrong. And so here today, I have the perfect guest to actually talk about what it looks like to govern a large, complex Snowflake installation, the challenges that come with having lots and lots of users who have the ability to run their own workflows, and making sure that you're doing this in a way that keeps budget in mind, because you can actually spend way more than you want if you're not actually monitoring this stuff. So Brad, why don't you introduce yourself and your background?
Sure. I'm Brad Culberson. I'm a data platform architect. I work out of the field CTO office at Snowflake. I work with customers every day as part of a Powered by program where we help them be successful and build products directly on top of Snowflake. I've been using Snowflake I've been at Snowflake for 2 years, but I've been using it for quite a bit longer than that. Previously, I was an architect at Twilio and SendGrid, where we also used quite a bit of Snowflake.
I'm Niall. I'm a co-founder of Select. We're building a cost performance optimization monitoring product for Snowflake. I'm also the creator of a couple of popular dbt packages, dbt artifacts, and dbt Snowflake monitoring, as well as being a maintainer of SQL Fluff. And before, Tristan, you wanted to say something?
No, that's cool. I didn't know you were involved in SQL Fluff.
Tristan just got very excited. Yeah.
And before starting Select, I was a data engineer at a few startups, and then most recently a consultant at Brooklyn Data Co, where I helped over 10 Snowflake customers optimize and lower their costs. So that's kind of what's led me to where I am today, building Select.
I'm very excited to have both of you on here because this is an attempt to cover the subject with the exact experts in the room. So I guess maybe let me just start off with a quick question, and then Julia will dive in from there. But Brad, for you in particular, how do you think that this overall subject has changed in terms of attention over the past, let's say, 12 months, and why?
There's much more attention pivoting towards, running systems, economically. I think we were in a phase of the economy where everybody was trying to grow at all costs for many, many years. Companies had, what I'd say is like euphoric growth. They were growing massively fast. They were trying to basically just throw money at problems, right? Because they didn't have enough engineering time or effort, and they weren't focused on actually running systems economically for years and years. The biggest goal for most organizations for many years were growth, as well as revenue. And we're seeing a rotation of that due to the economics we're in today, of a higher focus on running systems more economically. We also, I think, even before the last year, though, we were seeing this trend, I'd say for the last decade, from people just moving from on-prem fixed capacity systems into the cloud. So we were seeing this happening also around, customers were in constrained environments in the cloud, on-prem, moving into the cloud. They started getting a lot of access to things like unlimited compute. And that transition started like raising some awareness of, we may need to start thinking about this cost monitoring thing because it's no longer a fixed budget that I just paid for in a data center. So, I think the last 12 months, we've seen a rotation even heavier towards it. But also, I've been in architecture for many, many years, and a lot of my time is around efficiency and cost monitoring of organizations and also companies. I think a lot of the conversations I have with customers are focused on that now, but they have been like this for 5-10 years.
I think that's a really interesting point because a decade ago, it was the usage-based pricing as a concept was, not totally unheard of, but very uncommon. And when you are negotiating with a vendor to purchase a piece of hardware and stick it in your own data center, all the budgeting conversations happen up front and are kind of like baked into the spreadsheets, and they happen with management involvement and everything. But then when you're in a usage-based world, often every individual user has to, at least to a certain extent, think about cost-benefit trade-off of the thing that they just hit enter on. Is that fair?
That's a good summary. Historically, that was all just a fixed upfront cost. And no matter, teams would sometimes fight for resources, sometimes, not very successfully with each other inside of the orgs where it was fixed capacity. And now every new project and every new feature, all of it has additional costs because it is pay as you go. So all those teams building new things have to justify, this is what I want to do. Is it worth this much spend to solve this type of problem or not?
I think it was a shift too from an IT buyer to now the practitioner is also the purchaser in a lot of ways. And so you have a shift in who's talking in procurement conversations and then who has to be aware of what the budgets look like going forward. But I think it is top of mind for lots of people. So I'm excited about this episode because it allows the two of you who spend a lot of time thinking about optimization to share some of your expertise and bring your perspective to the conversations that are already happening. Of course, people are thinking about it because of uncertain economic times. People are looking at budgets everywhere, trying to optimize not just their warehouse spend, but their spend across all categories. But also, I think a part of it is because of the maturity of the technology. We're now 10 years out into having cloud warehouses, and you don't start adopting a new technology by thinking how to optimize it. You just kind of let it into the wild, see how people use it. And then after, it's almost a fallout of your success. Hopefully you're so successful on this platform that you have so much use for it that you start thinking about optimization. So maybe if we can jump into the conversation a little bit more, it's like when along that maturity curve are people thinking about optimization versus just pure, let your team go wild, see what kind of problems you can solve with your warehouse? And when should the conversation kind of shift a little bit into thinking about how to have checks and balances in place?
I think that point around usage-based prices is very interesting because we have flexible compute resources now and therefore faster iteration on data products than we've ever had before. And we can match compute resources specifically to each of those workloads as well. And so gone together, we have more companies using data than ever because the barrier to entry is lower and more users at those companies using data than ever before, which are all great things, right? But if we're not careful, we can end up spending more than we anticipated because we're using more resources than we budgeted for. And anyone can spend that money just by running a query. So there's more demand on data teams to kind of educate business users on best practices.
Now, this is the thing that software engineers, especially like DevOps engineers, experience with the hyperscale cloud providers too. I was literally just on Twitter and somebody was complaining about the free tier of one particular provider doesn't actually provide guardrails. And even on the free tier, you can end up spending yourself deep into a hole without realizing it. And anyway, so the data, as often happens, is experiencing similar things to software engineering, but is like getting to them a little bit later. Do you think that's a fair read?
I'd say so. We need more cost governance and kind of oversight for sure. So, and we also have more first-time database contract owners than ever as well, I think. And often people who are owning these vendor contracts haven't managed a data platform before or a software platform, to your point, which requires careful oversight
One of the things that I think is not a part of the conversation enough is people talk about cost, but they don't talk about ROI. And it's like you have to have that conversation because it's more important to think about what are the benefits to the business and what's the relative cost. And if you think about people's journey to cloud warehouses relative to what they were doing on-prem, the business benefit is just dramatically different. People start with a hierarchy of needs of like, first you need visibility, BI reporting. Okay, you could have done that maybe previously, but I'm seeing just a whole use of different applications for your cloud warehouse to build kind of operational analytics, things that maybe software engineers would have owned in the past. Of course, there's more machine learning workloads or data science workloads that can have direct impact to top line of the business. Do you think people are having the right conversations around cost optimization as an absolute scale? Or should they have a different framework of thinking about ROI? And how do you maybe change the conversation with your buyers and customers to think about the benefits that they're unlocking as well?
One thing I would think about, I liked your position there of ROI, is almost any system can be optimized basically forever. And often I'll tell customers, like, I could probably work on this one query for the rest of my life. And there's just so many ways to optimize things, right? But the real question there is this worth our time? Is it worth our engineering effort to actually do this optimization? And will we come out ahead, right? And does this project already have good margins? Is it already fulfilling the business's goal? When we go into new projects, it's amazing when there is actually budget and we kind of know, like, okay, what's the margin that's desired here? And what's the revenue this may drive? Or what's the business willing to spend to solve this shape of problem? And one thing that's amazing with us paying for specifically that project and seeing that cost accountability so clearly is we can see if they run over. So organizations can start tracking this and say, hey, we said we would spend this much. You're tracking towards it or you're not. Let's talk about this. And historically, that's been very hard because these have all been very highly shared systems. And you may have some people in there that were using a huge percentage of it affecting other users, but no one really knew that was happening. So I like the clear visibility that I think the cloud has provided and what we now have around these cost controls. And I like the rotation of companies to start looking at, like, what's the budget spend? Because any system can probably be optimized forever to get better and better margins, but it may take 1,000 engineering hours to gain 0.1%. It's like, well, that probably isn't worth that spend, right? So it's worth thinking about that a little bit. If a customer is successful and they're happy with something, I often am like, why are we here talking about optimization? Like, it sounds like you have great margins and it sounds like you're fulfilling your business need. That's amazing. Is there something else? Like, can we find something else to drive more business and get you more revenue and be more valuable? Because we could be getting to a point of diminishing scale and returns and using engineering resources in ways that's not as efficient, like, gaining 0.1% of efficiency on one workload when you could use that engineer to build a completely new product line or something, follow a completely new research project. Those things need to be thought out at the organization level.
I think that's really hard to do well because, we see it all the time with software engineering too. You need to be able to connect the people who are contributing to this kind of work to the business impact. And should they be the ones that have the decision power on, like, what is worth the extra percentage of optimization versus should they be focusing on a different project? And you can end up in situations where people are, unfortunately, given their seats, just have like too narrow blinders on what their priorities are.
What I notice is, like, KPIs aren't set ahead of time and goals aren't set often. So they didn't have a certain margin set for some, product they're developing, or they didn't have a specific amount of money they wanted to stay within for a certain research project. And then there isn't a goal. So people now every day question, should we have another meeting about optimizing? Because we don't know what the goal is for the spend. Like, if the goal of the spend is $0, you're tracking towards zero, you're going to be using engineers forever to continue trying to optimize those systems, right? It's worth thinking through if that's worth effort or not. Oftentimes I am involved and they are worth the effort. We're seeing massive improvements because they do have a product line that didn't get the margin that they wanted, right? They delivered a product line, they prototyped something. They're like, hey, the margin isn't where our goal was. I'm like, okay, let's look at it. And we find amazing ways to get them within the margin. But then we have a finish line. We say, hey, we hit the number. Are we done here? Can we move on and be happy and go on to the next project?
And I think as engineers, we often just enjoy thinking about performance and optimization and reading about it. And it is easy to fall into the trap of optimizing for optimizing's sake. So having an understanding of the cost of your data assets, which you can weigh up against their return, as well as like the opportunity cost of working on optimization, delivering other value to the business, is essential to have all of that information before you start on an optimization project.
Brad, you said something that was interesting to me was it's not always easy to have the visibility or do the attribution. And Niall, I know that's a big raison d'etre for Select, is helping people get to the fine-grained answers on, which workloads or which teams or which projects are creating big spikes in usage. Is that an unsolved problem today in getting the kind of visibility and monitoring that you would like in the warehouse? Or what are some ways that companies can do a better job of figuring out where there are opportunities?
I'd suggest starting with the native monitoring that's in your warehouse. So Snowflake has resource monitors and some high-level cost exploration dashboards that you can use. The challenge then is how do you action that data? So say a warehouse becomes more expensive. Actually working out why can be really hard, and especially in a warehouse like Snowflake, which builds a kind of compute level rather than something like BigQuery, where you can easily see your cost based on bytes that have been processed. So we've actually open sourced a cost attribution model in the package I mentioned earlier, which is that dbt Snowflake monitoring package, which attributes warehouse costs down to the query level. And once you have that, that's like the kind of finest grain that you can get to. You can roll those costs up to data assets based on kind of metadata associated with those queries.
Can you go into that for 1 second? My understanding, very imperfect, so I need you to confirm this. My understanding is that you would get that information from metadata tables that Snowflake surfaces and that you can just like write table queries on top of, right?
That's right. But Snowflake provides, I'd say, a fairly basic but kind of good experience for visualizing spend. But they provide this incredibly rich metadata as well in the usage views, which companies like Select can build on top of to build really comprehensive dashboards kind of aligned with specific tools and with other metadata to give you a view that's kind of relevant to your own platform.
I'll talk a little bit about Snowflake. I think in general, we do a very good job with data, and we drive our entire company based on data. Every query that a customer ever runs on Snowflake is logged. You can get to full query history. You can get all the information around, credits, consumption, seconds ran. You can get information around, who ran it, where did it run, which warehouse did it run on, when do warehouses start and stop, when do they auto scale up. All of this data is available. Like we actually share it back to all customers. It's also it is our largest data set that we have inside of Snowflake. The real pain that we see most customers fight with is trying to deal with this huge volume of data. I mean, this is a massive volume of data for some customers. And our visualizations are very high level. They're very simple. And a lot of customers end up wanting to use another tool to be able to really dig into it, right? And they can make some business decisions of how do they align their account topology, or their, are there teams or business units that own specific warehouses, and they can have some philosophy for tagging and other things that help them get their cost attribution better aligned and easily reported on. But they have to build that tooling on the data set that we provide for them. Like when you think about like the eventing of data, I think we have all of it available. But right now, a customer has to do quite a bit of work to actually like get insights into that massive volume of data that we're providing for them.
But I think that's not that different than, again, you would see at GCP, Azure, AWS. Like generally, the cloud providers are also focused on like making sure that they produce the data for you. And maybe they have some high-level visualizations too, but it seems like it's a fairly common pattern, the way that either customers can consume that data themselves or you can purchase a tool that kind of helps you with that.
It is. And I think we also we have sets of dashboards that customers can install into like their visualization tool of their choice. So oftentimes customers are using Snowflake are already using third-party tools for visualizations and those business intelligence. We have pre-canned reports for them that we're like, hey, we think these are things you should probably be watching at your accounts. Earlier was mentioned okay, this warehouse consumption went up. Well, we should probably have a graph on, the trends of warehouse utilization is there outliers, right? But in general, I think customers, making decisions organizationally for them can also help them get to faster insights of, hey, I know this team owns this warehouse. When this goes up, I can actually send them an email saying, hey, your warehouse utilization just went up. Could you look into it immediately, right? And that's something that we don't have tooling for right now. Customers have to build that on top of Snowflake.
When you help customers get better visibility and you give them dashboards to see where their spend's coming from, is it obvious how they can go and fix it? Or is it every customer has their unique snowflakes and they have to then figure out what to change in their organization to reduce costs? Or are there some like best practices or do these three things? And usually that can help dramatically in getting cost in a more manageable fashion.
I alluded to this earlier. I think organizations that follow Snowflake best practices of isolating workloads on separate warehouses, if you have a separate project, that project should be running on isolated warehouses that are clearly defined for that project. When customers are following those best practices, actually, it's quite intuitive what just happened. And when it's happening, they have to then hit up that team, or hopefully that team is actually watching those dashboards themselves. Like we're seeing a shift where teams are starting to take ownership of their own credit consumption. They're the ones that know what they're building the most. They're the ones that know, hey, did I do a deployment yesterday? Did I change something? Okay, that's probably what just changed this, right? So it's often no longer an IT team that's then saying, hey, I see your credit consumption went up. It's now commonly the team getting their own feedback saying, my consumption went up more than I expected when I made that change yesterday. And with that being timely, much easier for them to resolve than hearing about it at the end of the month when another team notices. Like we're seeing that more. Where this gets messier is where companies use a more traditional approach where they're used to using other warehouses where they just I'll use this big monster warehouse and I'll just throw everybody in it. And it's now just a potpourri of queries running in from all the different teams and projects and everything. Very, very hard to extract that. And you would have to do an immense amount of data mining inside of the data set provided to be able to determine who just did it. The data is there. Every query is logged. You would be able to backtrack it. But much more efforts needed than to actually, figure out what just happened. To me, when I see that happen, the first thing I do is work with the customer to start isolating the workloads because that's also high risk. Commingling those workloads is putting every workload at risk of getting affected by another workload. There's no reason to do that. By separating them out, we can often tune them for their own behaviors. A commingled workload means you're probably, you're working on the least common denominator there of, what are query performance needs and what's the most demanding piece of that. And often those turns into huge warehouses. And then you see very simple queries coming in and where I'm like, oh, I wish that wasn't running on that really huge warehouse because it wasn't isolated. And ironically, customers are all surprised when I'm like, if you split this workload into 10 separate warehouses, it'll be dramatically cheaper. They're like, that sounds more expensive. I'm like, no, because each one is well-sized to the workload. So it's very optimal for you. And then when I go through that conversation, it helps them rethink of how to use Snowflake and how actually our workload isolation gives them capabilities. And it starts thinking through a new thought process of no longer commingling for efficiency, more of tuning for specific workloads and then, suspending those based on the workload and sizing those based on the workload and auto scaling those based on the workload. When that happens, we have easy cost attribution for projects or teams or projects.
Niall, the conversation around who does this, I think is a really interesting one. We frequently talk about the different roles in the data team, but the ecosystem generally hasn't had a hat for like bad cop who comes in and tells you you're spending too much. Do you see the user of Select as that person on the data team that they're governing their own? Or is this like somebody that works for the CFO that has been tasked to come in and yell at you?
That's a great point. Yeah, we see quite a lot teams with a kind of query cop, as you called it, another person monitoring the instance, who's run this really long query. That's definitely something that we can automate and do a better job of. So we see the users of Select as a few people. We want to make it easy for people who are managing the contract to see, are they on track? Are they over? Therefore, do they need to work with the people they manage to help get that down? The architects who are probably managing the account and the configuration as well, so they can see how well those warehouses are being utilized, to Brad's point around ensuring things are well sized. But then individual users of the platform as well, people can get feedback on the queries they're writing and become better educated on how to use the platform well. What a good query looks like, what are bad query patterns to use.
It's fascinating to see just how different companies operate. Like when you were talking about it, Brad, some of the things that I've seen just through dbt users is they'll have like one big dbt DAG and they want to use different warehouses depending on how long the model is running so that they can have like really dense bin packing as they have threads that course through your dbt DAG. And what I'm hearing is maybe different needs for different warehouse sizes, more dynamic power given maybe on the project level, maybe it's on the model level, maybe it's on the team level. And this ends up being often trade-offs between like, do you want speed or cost, or how do you actually define what you're trying to optimize for? And it can get really complex quickly. Is this something you think that the onus is on the warehouse to try to help the customer make the best decisions here? Or is it like, hey, we give you a lot of tools and you can pick your own adventure? Or should a third party really be the one that can help people decide on how to pick the warehouse sizes or where to make the investments?
The learning curve for teams building on Snowflake, I think, is a historical one where often they just pointed at one warehouse that had fixed amount of compute and then the thing just ran, right? Now there's a lot more options. So Snowflake's giving a lot of capabilities to those end users now to say, hey, do you actually want super high concurrency? Do you have a really complicated query you'd like to run extremely fast? Would you like to throw a lot of compute power all at that one query? And is it efficient to do so, right? Some queries do distribute really well and can run very well over thousands of cores. Some can't. Right now, it is on the onus of the builder to make those decisions and those trade-offs of saying, is this a complicated enough thing that I want to run a larger warehouse? Or do I want to run this with higher concurrency, right? I think in DBT case, I work with some people that have some projects where they actually want to spin out a large amount of concurrency in there, where they're building several different models, and it actually getting concurrency there, many clusters inside a warehouse is better than having, a bigger one in that case. Right now, I think that is on the onus of the engineer. I do think third parties could probably help guide. Sometimes I'll look at a query and I'll see a really complicated query running on like an extra small. And I was like, oh, obviously like that, it would have been very economical to run that up to a much, much larger warehouse and you would have been happier with the performance. I see that because I've been using Snowflake for many years. It's very intuitive. I see it in a second and I'm like, oh, obviously. But some customers haven't used Snowflake for years and that isn't obvious to them of the right warehouse sizing. And right now, I think third-party tools or more mature teammates are helping them say, hey, I've been using Snowflake for a while. Let's think about this other pattern and see if that actually can solve our use case better. I think one thing I do like about Snowflake in this case, very trivial to change your mind. In architecture, we talk about two-way doors versus one-way doors. It's very easy to run that project with different warehouse utilization and use different warehouse sizes and configurations, and then click the go button and see the performance of it and see what your costs were. And it should be as much as a configuration change to completely change the way it's executed, the type of compute it's running on. And then the end user can decide, was that more economical for them? I can't say how fast that job needs to run. A customer may be like, this has to run in 10 seconds or this needs to run in 45 minutes. Those are two very different goals that would require a completely different, type of plan of action against it.
Okay. Can we get geeky here for a second? You're talking to an audience of analytics engineers. You kind of made a statement a second ago. You said some queries are better at distributing horizontally and some are not. When you say that, I think back to a project that I was working on. It was for a company they were a DMP. They processed clickstream logs and like a lot of clickstream logs. And I think the data set that I was working with was somewhere in the realm of 10 terabytes. And there was a small number of models that were processed a majority of that data. And so I would watch them run and try to observe how they perform differently on different warehouse sizes. I observed a pretty meaningful nonlinearity for these particular models as I increased the warehouse size. But on some models, you see pretty much linear increases in performance can you explain like what actually is going on? What are some things that can cause incremental dollars in warehouse size to directly flow through to performance and where sometimes it doesn't?
When I look at like trying to help a customer with, scaling up a workload, there's two different things I'm worried about. It's one, can I get it to run fast enough? And then, can I fully utilize the warehouse? Because I also want to be economical with that. Mm-hmm. Some will just be like, hey, I want to run this huge Excel. I'll just throw it on there. It's got to be fast, right? There's cases where it won't be, like you just mentioned. The cases I start looking for is the size of what's the query, like the data set size. So how much data is that query processing? In Snowflake, when you look in query history, we tell you exactly like gigabytes, terabytes scanned for that query. We'll tell you the number of micropartitions that were scanned. As that number increases, we have much more opportunity to distribute that across many, many cores. So many micropartitions, many cores, we can distribute that well. The smaller the query is, if it's scanning one micropartition in Snowflake, it will not scale beyond one core. So it doesn't matter if you throw a quadruple XL on that thing, it will be the same speed as an extra small. And it'd literally be orders of magnitude cheaper. So it's worth thinking through that volume of like how much data is getting queried during the query itself. There's something else that happens in data that can also affect this. It's fairly uncommon, but there's also data skew, which this audience is probably familiar with, where one micropartition could actually have like a lot of the interesting data for the specific query. So something might start off with a bunch of micropartitions. So maybe it is a terabyte of data. Many micropartitions start at the beginning of the query, but it happens to be that like one micropartition that had interesting data 3 months ago is actually where all of that query focuses in on.
Because the where clause limits you down to only processing that data set. Okay.
That's it. So the beginning of that query distributes really well. And like the beginning will be like, oh, wow, so fast. We just distributed it really well. And then what happens is that very large cluster did a good job of filtering, but then the rest of that query gets processed by a few cores because it goes down to 1 or 2 files. So that's where you'll see the query kind of stretch out. The more processing that gets done after filter there, if there's like some window functions running in there, there's some joins to other tables. Now you're stuck down to being, running on one core because it's a very small data set at that point. Those are actually quite rare. I mean, I get pulled into a lot of customer conversations. I see like 1 or 2 of those a month, but I see a ton of them where customers have thrown way too big of warehouses at problems that actually aren't very big data sets.
The way that we often recommend that Snowflake users configure their warehouses is to always default to the smallest warehouse, like even default to an extra small. Where a query is too slow, or you start to see things like remote disk spillage, that's pretty much just like a dead giveaway that you should use a bigger warehouse. And where you need to do that, you should run just those queries on the larger warehouse. Leave everything else on the smallest warehouse that they run quickly enough on. And you're going to get really good cost and performance efficiency then. I've seen DBT projects double in speed end to end, or sometimes saving costs just by running the models on well-sized warehouses.
The other thing I look forward to there is like when I love starting them with an extra small. It's exactly what I would have them do too. But then if they move to a small, they should see double the performance. Like if that query actually distributed well, Snowflake costs are double. So we charge 2 times more for a small than an extra small. We have 2 times the amount of compute, 2 times the amount of memory. It should run 2 times faster. If it didn't distribute well. That normally happens when there's not enough data query that I was talking to earlier. But if a customer then says, hey, I want this to run faster, I'm like, well, run it on a medium. If it's 2 times faster, you're spending the exact same amount of money and you're getting it done faster. Like these are all elastic cloud resources here that you're paying by the time that's actually getting used. So, if someone's frustrated with like an extra small taking 30 minutes, I'm like, well, run it on a medium and have it in 7 minutes or something.
Okay, elastic cloud resources. You're almost definitely going to say no comment to this question, but I have to try you. In the hyperscalers, there's a concept of a reserved instance. And this is often a way that infrastructure engineers will optimize costs in hyperscaler cloud environment. You have some baseline and you're like, I know I always need these resources. And then you call up your rep and you say, I'm going to purchase reserved instances for this set of resources. And then you have whatever, regular or spot instances or something for your more variable capacity. I know that this model is not a thing that any of the data clouds do today. Do you think this model makes any sense in a data context?
Yeah, for sure. There's other inputs to this equation. It's no longer just about spot versus reserve. It's also about the architecture of those instance types, different cloud providers with different performance characteristics of different instances. There's many levers in there that are happening for customers that are like thinking about this instance sizing. Snowflake does try to simplify this dramatically for end users. Like we think our warehouses that are fairly simple, size by t-shirts, very easy to understand in size. We'll deal with the complexity of picking the right instance families for customers, picking whether we should be using reserved or on-demand or spot instances for them. And we think we're economically driving that number to something that makes sense for end customers. In general, like one thing Snowflake does, I think is amazing is we actually have our own hot pools of resources. So when you have for a warehouse in Snowflake, you get it in like second. That's phenomenal. If we had to go procure an instance, spin it up, install some software, attach it, it wouldn't be a second, right? You could not have the same dynamic access to compute as you have in Snowflake. And these tools allow us to have customers build things that have massive spikes in load. Like you can have something that comes online and asks for 1,000 cores, have it very, very quickly, execute, spin down and be done. All of that comes in and goes away very, very quickly. Very rare in our space to have that dynamic access to compute. Oftentimes customers are like, hey, couldn't I do this more economically? And I'm like, let's put your workload on Snowflake. I'll prove to you that it's economical and it solves your business case cheaper than other technologies. And then you don't have to worry about the complexity of all these other things, which we are dealing with in the background for you.
It's super interesting that the trade-off in less control over, you use t-shirt sizing instead of all these complex, it like increases the pool size. And that increased pool size gives you this whole other benefit that you wouldn't get otherwise. That's neat.
Yeah.
That's really the beauty of the cloud warehouses, that you can dynamically spin up compute and storage separately, and it allows you to try different things. It allows you to have costs to fit your needs, your workloads better. One of the things that I think is pretty interesting of more recent trend is there's been all these other options for storage, which is traditionally the more cheaper part of the equation when it comes to compute and storage. Compute is where the expense is, but Snowflake has made some investments to integrate natively with Iceberg. There's, of course, other table formats that are becoming available, like Delta and Iceberg and Hoodie are the three big ones. Is that just for cost reasons? Is it because the data is structured in a different way? How has maybe the introduction of the open table formats improved people's optionality when it comes to where they want to spend?
I have several customers right now that are in the preview for Iceberg. They came in for many reasons. I think a very common reason is just like a migration plan of, I have a lot of data in a data lake today. I'd like to try to, use some existing tooling as well as start migrating things into Snowflake. Some things make sense in Snowflake. They understand that and they want to move it in quickly. Others, they want to leave running in other systems. That migration path tends to look easier today using Snowflake as the bridge to make that work. I have other customers also that, especially we're seeing a huge acceleration in the security data lake area, building on top of Snowflake.
Mm-hmm.
These are many, many, many petabyte data sets that are growing extremely rapidly. And there's an active query window of almost all those data sets are getting queried within the last week, the last 30 days. But they want to be able to age out years of data into very economical storage. And right now, you look at like, S3, infrequent access, as well as Glacier and other things. You start thinking about running Iceberg on top of that or using external tables in Snowflake. There is a way to pair those together where you could load, a hot data set into Snowflake's native storage, which is going to perform better and be faster, but then also it gives them a good path to aging data out. And then joining that together for queries. So occasional queries coming in there, joining into that, that's great. We can still query into, a decade of data or whatever's in there. But the most recent data, often they're loading in Snowflake just for our performance gains that we have. I think Iceberg's an amazing format. I think I'm excited for it. But performance will still not match Snowflake's native format, sir. So I still suspect we're going to see a combination of both.
You said something about security data platform. Are you talking about just data retention policies and there being a risk if you have endless data retention? Or can you say more about what you mean around security?
A lot of the companies building security products on top of Snowflake today are working on data sets that are just huge, right? We have agents running on systems all over the place that are sending data into Snowflake continuously. These data sets grow very, very rapidly, many terabytes an hour. At that data growth, they often have a strong incentive to want to age that out. Like it's not hot after 30 days. They're like, well, with Snowflake, it is affordable storage. It's well compressed, but also like Glacier is looking more affordable here, right? So they want some plan of getting from Snowflake's native format that's compressed and performs very, very well and is pretty economical to something that is fairly slow, but also still accessible and I can still query inside those systems.
Jeremy Cohen, if you're listening to this, I want a materialization that allows you to automatically age data out from native file format into Iceberg, and it just kind of manages. And then you create a view on top that unions both of those together. I mean,
wow,
that sounds great.
This is insane. We just observed Tristan, the CEO of DBT Labs, give her a product request.
Put it in the roadmap.
We literally have a customer right now in private preview doing exactly that.
Makes so much sense.
Yep.
Before we wrap up this episode, people are thinking about cost optimization because they have to be more careful about where they spend, but maybe it's too much focus is being spent on warehouse spend because that's really just like one part of the equation. It's really a smaller part of the equation. What advice might you have for data teams as they think about treading carefully in uncertain economic times? I was giving a talk on this recently, and for me, I think the last thing you want to do in uncertain economic time is to lose the visibility, making sure that you have all of the data at your fingertips so you can aid your business, thinking about data velocity so that they can make smart decisions when optimization and prioritization is more important than ever. Thinking about how do you have a resilient data team in the face of maybe headcount changes. So up-leveling people's skill set, having more people participate in the workflow, making sure that you don't have any risks around a data domain expert if they leave your organization, not having any areas that rely too heavily on people. And then maybe the last thing that I think people should be thinking about is focusing on revenue generation. So how can you help the companies do more, whether it's machine learning or it's operational analytics? How do you associate yourself with business impact rather than cost optimization or being a cost center? Are there other things data teams should be thinking about in these uncertain economic times that's maybe above and beyond just focusing on how much they spend on a warehouse?
I think marketing teams are great examples of teams who do investment and return attribution really, really well. They measure everything, often with help from the data team, but data teams often aren't so good at measuring themselves. I think part of that is because it's really hard. Like you can't say we solved this thing because of this dashboard, but there are other things that you can do to identify value. Business operations, I think, especially now when we're not just using data for BI, but for driving workflows, identifying operations that data teams enable is a great way of identifying value within a business, reducing inefficiencies, just reducing people's time to action on support tickets and things like that. And I'd also recommend that businesses create a way for their users to share the value that they've achieved through the data platform back to the data team, and creating a feedback loop there to help people really focus on what's driving value is really important.
I have a few tips. As customers are more, sensitive towards costs, it's the teams building these things should start focusing on a few different areas. I think one is start with smaller projects that have like smaller data sets. Maybe don't train a model on the entire data set to start with. Start smaller and actually understand the costs on a smaller running system before you grow the data set to petabytes. I think one thing about the cloud is we can help you solve anything to any size of problem. But the challenge there is to understand the cost before you jump into that. And you can understand that usually really quickly on a small percentage of the data set or a smaller piece of the data set. Also assume, like earlier was mentioned, assume the smallest warehouses and make some decisions here where you're just not throwing compute power at something. Don't go to, run a transformation pipeline and just choose a 4XL. Probably not the default choice. Is start with the extra small and then ramp up if that doesn't perform well, right? Because underutilizing those large warehouses is leaving a lot of wasted credits on the table that could have been used for other purposes. But I love the business visibility. I think early in the project, setting a budget or a margin goal or something helps out considerably here. So everybody knows what that goal is tracking towards, and they're looking at a dashboard, hopefully, that visualizes that. So they can quickly make a decision saying, is this going well? Is it not going well? Do I need to dig into something, or do I need to stop a project or, revisit something? I think it's pretty important because often we have dashboards people look at and they're like, I don't know what the goal is. So I don't know if this is good or bad. Person look at the dashboard should probably know if this is good or bad, and whether it's tracking to the right number or not, and whether they need to dig in and if something's urgent or not.
I love all that advice. And we're going to wrap up. We ask this of all our guests, but looking 10 years out, what do you hope will be true for the data industry?
I hope we have less data moving to do. I think open table formats are a really good start, but I wonder if we'll see commonplace adoption of technology, either Snowflake's Unistore or similar to that, or whether we'll still be using completely separate databases. I'm really excited to see where that goes.
I'd love organizations to gain more ownership of their own data. So they're no longer, moving data to partners to help them solve challenges, or, providers to be able to help them. The sovereignty of that data, I think, is extremely important in the future that we have. I'm excited for customers to be able to embrace and own their own data. I think I'm also excited just about the simplicity of where I hope, Snowflake Data Cloud and the future is, where, hopefully you have one database system that can solve many shapes of problems. Historically, everybody's been moving data around to every engine that exists, and organizations have, a plethora of technologies they have to manage and own, all because they have different performance characteristics. And I hope we can solve that. I hope that actually engineers can actually go to the business problems and say, hey, this database engine can solve many different shapes of problems. And I don't have to go pick a database engine for every problem and then just focus my entire organization on just moving data around and the latency of all that data between all those different systems. And then the governance of all those systems. I think, in the future, it's not just managing those, it's also governing those and making sure that they're well secured and the right people have access to the right pieces of that.
Julia, I'm going to jump in and answer too, because, normally this is just our guest, but this is like a thought process that I've been on both sides of. I'm a data practitioner. I'm also a person who is in control of a burn number. Like, I want to make sure that we don't spend too much money as a company. So I care a lot about this. I'm excited about all of us having gone through this experience together as an industry. I think it will make us better at stewarding our cloud resources. Like, it will cause us to build product functionality that allows us to do that. It will cause our teams to develop the muscle for doing this, because the economy goes through peaks and valleys, and that is how it has always been, and it's how it will always be. So we will come out of this period, whether it's in 6 months or 18 months or whatever it is, and we will go back towards the greater focus on providing net new value. And as we do that, I think we're going to do it with much more well-built muscle for doing it in an optimal way.
Couldn't agree more.
Thank you.
Thank you.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? Email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.